Okay, so in 4.2, we're gonna solve quadratic equations by graphing. All right, so the standard form of a quadratic equation is this, ax squared plus bx plus c. We were doing that last time, right? And then a, b, and c are integers. Now, the solutions are called the roots of the equation, right? So when you solve this, set it equal to 0, you solve this, x equals -3, x equals +2. Those are called the roots of the equation. One way to find what the roots are is to find the zeros or the x-intercepts. So now take a look here. I have 4 terms highlighted here. Solutions, roots, zeros, x-intercepts. All 4 of these things mean the same. The x-intercept, we know what that is. That's where the graph crosses the x-axis. Those are the solutions of the equation. They're also the roots. They're also the zeros, okay? So take a look. There can be, if you have a parabola, there can be 3 possibilities on how this parabola looks. In the first case, the parabola looks like this, where it only touches or crosses the x-axis at one point, so it has one real solution. Or the parabola might look like this, where it hits the x-axis at 2 points. Those have 2 real solutions. Or if the parabola just floats on top or at the bottom, then this has no real solution. Okay? Okay, questions on this? All right. So, okay, what happened here? These are all from like, oh, what the heck? What's, okay, oh well. Okay, so let's find the solutions here. So here, what are the solutions to this? There are these points where they crosses the x-axis, right? So, right, 2 real, but we actually want to find what the solutions are. So it's x equals 1 and x equals 6. Okay? What about this one? What's the solution there? There is no solution. What about this one? What are the solutions? X equals -4 and +4. And then for this one, it's just x equals -7. Okay? Okay. Now, go ahead and take out your calculators. Why is it doing that? All right. Okay, so we are going to, all right, so we're graphing this first equation. I put it in my F1. I press enter, and that's what I get. Okay? Now I want to find the zeros. So take a look. There are 2 distinct separate points that I have to find. One on the left, one on the right. So I have to do this operation twice. Okay? So here's what you're going to do. Use the steps on top of that page. So menu, analyze graph. What are we finding? 0. Okay, we want the zeros this time. So here is 1, 0. I go to the left of it, highlight the 0. Do you see where the 0 is? It's that point where it crosses the x-axis. So I got 3.55. So here I say x equals 3.55. Now what you're going to do is go back to menu, analyze graph, 0. Now you want to find that other point to the left, right? So here, I get 8.45. Okay? Next, press Dock B, clear this, and you're going to plug in this next function. But before you plug it in, we have to bring everything to the same side, right? So we're going to add 3x to both sides. So this is going to be 13 minus 4x squared plus 3x equal to 0. All right, so go ahead and plug it in and find the zeros. So x equals negative 1.47 and 2.22 for this one. All right. Now, so section 2 is actually short, but we're not going to stop here. Before we do section 3, we have to review some factoring, right? So if you can see here, oh my gosh, these are all like, okay. So if you can see here, section 3 actually starts on page 11, right? But before that, we have a whole bunch of like factoring practice that we want to do. All right? Okay, so we're going to factor them actually.
Wait, so that was
okay. That was the last of section 2. It's a very short section. That's why I want to use this time before we go on to section 3 to review some factoring from before. Okay. All right. So let's move on to page 7. I have, a couple of pages of just factoring review. And then, next time we're going to do the next section. Okay. So go ahead and turn off your calculators, and you can actually put them away. We don't need them right now. Okay. So let's review some factoring. First off, we're going to start off by factoring out a GCF, right? The greatest common factor. So if you take a look here, between the 16a and the 4b, what can I factor out of both of these? The 4. So when I take out the 4, I get 4a plus b, and that's the factored form. Okay? Here, what can I take out of the second one? 9, and I get x squared plus 4. That's completely factored. I can't go anymore. Okay. What about the next one? What can I factor here? 4 and r, right? So from the first one, I get r plus, what do I get from here? 2s plus 7. Okay, so what are we doing behind the scenes mentally? If I factor out a 4r, it's like for each term, I'm kind of mentally, right, dividing by 4r. So 28 divided by 4 gives me 7, and the r's go away, right? So in the background, in my mind, that's what I'm doing. Okay, what do I factor out of here? 6x. How about a y? Yes, a y too, because there is a y in each of them, right? Y. So here I get 2 left over. What about for the next one? 4y. What about for the next one? Negative y cubed. Correct. Okay? You guys remember this? Wasn't it so much fun when we did it in algebra?
No.
Yes.
Yeah.
Oh, you guys are being party poopers. Okay.
I don't remember much from algebra.
Well, that's why we're reviewing, because it's been a while. Okay, so now factoring trinomials, right? What's a trinomial? How many terms does a trinomial have? 3, right? So before you even start to do anything, you have to first see if there is a GCF that you can factor out. After that, there are, a couple of things we're going to do. So one is factoring a trinomial. So remember, when we factor a trinomial, we get the 2 parentheses, remember? And then you put x and x. And remember how you have to come up with 2 numbers that they add to equal b, and then they multiply to equal c. You guys remember that? Okay, so that's what we're going to do here. Okay, so for the first one, what can I factor out? A 6 and an x. So I get x minus 3. And that's done, right? I can't go anymore. Okay, next one, Can I factor out a GCF?
No.
No. So I'm going to have two parentheses here. So I put x and x because together they're going to give me x squared. Now what I need are two numbers that multiply to 16 and add to negative 10. So what are some ways that I can multiply two numbers and get 16? 8 and 2, but also negative 8 and negative 2, right? And then also 4 and 4, but also negative 4 and negative 4, right? And then there's also 1 and 16 and negative 1 and negative 16. So which of these all multiply to 16, which of these add to negative 10? Negative 8 and negative 2. So this becomes negative 8, negative 2, and then I'm done. Okay? Okay. So let's...
Just a little bit, I missed the... Oh.
Yeah. Okay, so let's do another one. These kind of like appeared. I don't know what's going on here. Okay. They won't go away. That's so weird. Okay. That's the... I know. So you know what these are? These are like the points I made like here.
Memorize.
Yeah, they're the stuff I wrote here. And then they just got like copied over everywhere. It's so weird. Like, this is the weirdest thing ever. Okay, whatever. It's like a math ghost. Oh my God, remember how, like, so we had confidential on all the pages, but now we have this on every single page. This is so weird. All right, whatever.
When you get chills, like, all over.
Yeah, that's a ghost.
Yeah, it's like someone walking through you.
Right.
Ooh,
That's not true. Okay.
Really? 'Cause it just happened to me like a minute ago, baby.
I think it was because you were just so like deeply affected by the math and you just got, it just gave you goosebumps. Okay, so let's factor this. Boom, 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 boom. So I get x, x. I need two numbers that multiply to negative 20, right? So now they can't both be positive and they can't both be negative. One has to be positive and one has to be negative. So it's like, 1 and 20, right? 2 and 10. 4 and 5. But which one of these, if I combine them, could possibly give me a negative 1? Negative 5 and 4. This one, right? I can make it negative 5 and positive 4. They do add to negative 1. And so that's my factored form. Okay. Next. Can I factor out a GCF there? No. So here, okay, so how do we get 28? 1 and 28, 2 and 14, 7 and 4. Okay, so which one of these do you think I can put here? 7 and 4. So x, 7 and 4. But now they have to...
Negative 11, you have to get 2 and 14.
Well, okay. So what if I make it negative 7 and negative 4? Now they add up to negative 11. But if I do 2 and 14, it only combines to like either 16 or 12. Yeah? Yeah. So, okay. So, let's see. Oh, 4 and 7, sorry. Okay, so a little like tip and trick for you, right? If you have a minus and then a plus, in the parentheses, you're always going to have minus, minus. Okay? All right. So here, can we factor out a GCF first? Yeah. A 2. So I get x squared plus 3x minus 18. So the 2 stays. It comes along for the ride, right? Here we're going to get x I need two numbers to multiply to negative 18, but add to 3. Negative 3 and 6. Right? Do you see how when you add these, you get positive 3, but when you multiply them, you get negative 18? Here, what can I factor out? An x. So I get x squared minus x minus 20. That's the same thing as before. So it's x times x minus 5, x plus 4. Okay? Now, what if when, that first term a isn't equal to 1? What if you have a coefficient here? So there are lots of things we can do here. Okay? Okay, so I'm actually gonna show you this way first. I think it's easier to do it this way. Okay? So here's what you're gonna do. Multiply the coefficient to the constant term. Okay? So what do we get? X squared minus x minus 20. Okay? Now, we're going to factor into two binomials. Again, this is the same problem as we were doing before. X minus 5, x plus 4, right? Are we okay with this? Now, but look at this. There was a 4 here. We took it out. So you know what we do? You put it back in both places. Okay? Next, you have to reduce one or both of the binomials so they have no common factors. So for example, look at the first one. Is there a number that you can divide both of these by? No, so you leave it. Is there a number that you can divide both of these by? What? 4. So you divide by 4. So finally you get 4x minus 5, x plus 1. Okay? All right, let's do that. Let me give you an example. Okay, so how does that sound? Good? Okay. All right. What about difference of squares? Right? Take a look at this pattern, difference of squares. When you have a perfect square and a perfect square and you're subtracting them, right? So here's what we do. 2 parentheses. What's the square root of the first one? A. What's the square root of the last one? 5 plus minus. Okay? All right, go ahead and do the next one. Perfect square. You put 2 parentheses. Go ahead and do that one. What do you think? What do we get for this one? Yeah.
9 plus t and then 9 minus.
Exactly. All right, so what about for this one? What do you guys think?
9 minus t? If it's a positive. Because the t is.
Because, so you take the square root. It doesn't matter, right? There has to be a minus in the middle for you to be able to do this. You take the square root, 9, you take the square root, t. One has to be a plus, one has to be a minus. Okay. So this one, you take the square root of this, what do you get? 8g. You take the square root of the other one, what do you get? Okay, one gets a plus, one gets a minus. Okay? Ooh, what about this one? X squared and 2 and 2 plus minus. Okay, the very last one is if you have a perfect square trinomial. This is a pattern. Take a look. This is a perfect square, and that's a perfect square. So look, perfect square, perfect square. The way you do this is like this. Okay? Take a square root of this one. Take a square root of this one. If there is a plus here, you put a plus here. Okay, what about this one? Look. Perfect square, perfect square. So we do it this way. Look, there's perfect square. How many terms are there? 3. So you only do this if it's 3 terms, perfect square, perfect square. Take the square root, take the square root, minus here, minus there. Okay? All right, go ahead and do the next 2. I'm gonna give you 30 seconds. On your mark, get set, go. Wait, 30 seconds. Go, go, go. Oh, you're right, there isn't.
For 10. Yeah, like b ends with 10. There's no perfect square for 10.
So then we can't factor it like that. Let's, okay.
Do you factor like the other ones?